Hey everyone, this is a short video on reactions involving alkanes. Alkanes are saturated hydrocarbons, as all the carbon atoms in the molecule are already bonded to a maximum of 4 other atoms. Therefore, an addition reaction is not possible with alkanes, as further atoms can no longer be added to the compound. However, a very special type of reaction that is possible with alkanes is substitution. UV light is required to initiate this type of reaction, as a vast amount of energy is required to overcome the activation energy of the reaction. Please keep in mind that UV light, it is not a catalyst, but merely a source of energy that is required to meet the activation energy. It does not lower or reduce the activation energy by any means. This is an example of a substitution reaction between propane and bromine gas. In the presence of UV light, hydrogen atoms of the propane molecule can be replaced by the bromine atoms in the halogen gas, resulting in the formation of a haloalkane, which is an alkane molecule bonded to a halogen atom. An important thing to keep in mind is that substitution reactions can continue replacing subsequent hydrogens of the same molecule. This equation only shows a mono substitution, where only one atom has been substituted by the bromine atom. It is very likely that in a reaction between propane and bromine, that more hydrogen atoms will be replaced or substituted. Cracking is a reaction whereby long-chain alkanes, that is alkanes with very large molecular weights, are broken into smaller hydrocarbons, including alkenes. This reaction requires a large amount of energy, which is the reason why it always requires a catalyst, which reduces the activation energy of the reaction. In the two examples shown, a much larger hydrocarbon, or alkane, whether it's in a gas form or liquid form, in the presence of a metal-based aluminium catalyst, are broken down into a smaller form of alkane with 7 carbons each, and more importantly, the formation of alkene. So the reaction of catalytic cracking converts a large alkane into a smaller alkane, and also an alkene molecule that's much smaller in size. Combustion is a very common reaction involving alkanes. This is because alkanes are very volatile and flammable compounds. Combustion is an exothermic reaction that is irreversible in nature as it goes to completion. There are 2 different types of combustion reactions. Complete reaction, or complete combustion, produces carbon dioxide and water only. For example, the combustion of octane, that is petrol, in the presence of enough oxygen produces carbon dioxide gas and water gas. Incomplete combustion occurs when there isn't enough oxygen, that is when the oxygen is a limiting reagent. In this type of combustion, varying amounts of soot or carbon and carbon monoxide are produced. Incomplete combustion of octane produces carbon dioxide, soot, and water.